so before we start section 1.2, let us talk about some of the concepts we will be using in this course, okay? The first concept I want to talk about is the slope. Do you remember what is the formula of a slope of a line that joins 2 points, x1, y1 and x2, y2? Do you remember that? We denote the slope by m, right? And the formula for m is we do y2 minus y1 over x2 minus x1. That is rise over run, right? So, or you can write this way too. It is the same thing. y1 minus y2 over x1 minus x2. You can do that way too. But what it is not possible is it is not equals to y1 minus y2 over x2 minus x1. This is wrong. Why is that? Because if you want to write the 2 subscript 2 first, you need to have the same thing for x and y, okay? So y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Either one works, but if you switch those subscripts, then it doesn't work, okay? Because how did I get this one from that is I took the negative, I multiplied by the negative sign on top and bottom. You'll get negative y2 plus y1 divided by negative x2 plus x1. That's what it is, okay? That is the formula for slope for a line joining the points x1, y1 and the x2, y2. Also, another thing that you saw in the college algebra is equation of a line in point slope form. Meaning that if you have a point given, x1, y1 given, okay? And if you have a slope of a line, m is given, then how do I find out the equation of this line? The formula is y minus y1 equals to m times x minus x1. You see that? Y minus y1, this is given to you. x1, value of the x1 will be given to you. Value of the y1 will be given to you. And value of the m will be given to you. And if these three things, a point, x and y value, and the m, slope, are given, then the formula to find out the equation of this line is y minus y1 equals to m times x minus x1. You will plug in y1, m and x1, and then you will have just x and y and some constant left, okay? So that will be the equation of the line. So the next thing I want to talk is the functional value. What do you mean by functional value? Suppose y equals to f of x is a function, meaning the fx can be anything. It can be x squared or x cubed plus 1, x squared plus 5x plus 2, anything, right? So if you want to find functional value at x equals to a, the functional value is fa. That's what you do. What you do is you replace x by a, okay? For example, if you want to see one example, suppose let f of x equals to, say, x squared plus 5x minus 2. Suppose you want to find out f at 1. That is the functional value of fx at x equals to 1. Okay, that's what it is saying. So x equals to 1, we replace all x by 1. So f1 is the functional value, that is 1 square. I'm replacing all the x by 1. Okay, 5 times 1 minus 2, that is 1 square is 1 plus 5 times 1 is 5. So 1 plus 5 is 6 minus 2 is 4. So the functional value of this function at x equals to 1 is 4. What does that mean? So in terms of the graph, the functional value is height of the function, okay? The height of the function at a particular point, okay? For example, if you draw the graph of this function, it will look like this. There is negative 2 there, okay? The graph of this function will look like this, okay? And you want to know what is the height of the function at x equals to 1. At x equals to 1, the height of the function is that one, right? You see that? At x equals to 1, the height of the function is that. So that is basically 4. So that's what it means. So basically the functional value of a function is the height of the function at a particular point, okay? So sometimes at this point, the height is on the negative side, right? On below the x-axis. So we write negative some number, whatever number you get when you plug in that point. So in the graph, the functional value of a function is basically the height of the function. Okay, so the next concept I want to discuss is graph of a function. You guys know how to draw the graph, right? How do I draw the graph? If the function is given like this, basically fx is, you can write y equals to 3x plus 1, right? Now to draw the graph, what you do is basically you make a chart, right? What you do is write down x and then write down y. Now pick different values of x and then plug in here and then find the functional value or find the y value or find the height. Okay, so let me pick x equals to 0. If I pick x equals to 0, what do I get for y or fx? 3 times 0 plus 1 is just 1. You see that? If I pick x equals to 1, what do I get? 3 times 1 is 3 plus 1 is 4. Okay, and if I pick x equals to -1, what do I get? 3 times -1 is -3 plus 1 is -2. You see that? Let us pick x equals to 2. What do you get? 3 times 2 is 6 plus 1 is 7. And how about x equals to -2? So when you pick the x values, if there is a restriction, you pick only from that region. But if there is no restriction for x, you can pick some positive values, some negative values. Okay, if you put -2 for x, 3 times the -2 is -6 plus 1 is -5. So these are the points. Now what you do, you plot that point. 0, 1, 1, 4, -1, 2, and so on. Okay, so what you do is, let us plot those. 0, 1. At x equals to 0, it is 1. That is 1 point. At 1, it is 4. At x equals to 1, it is 4. Let me do 2, 3, 4, 5, 6, 7. And then here, let's do -1, -2, -3, -4, -5. Okay, you can do -6 as well. So at 1 it is 4. Y is 4, right? 1, 2, 3, 4. This is at 1. And at -1 it is -2. You see that? At -1 it is -2. And at 2 it is 7. At 2 it is 7. Right there. And at -2 it is -5. At -2 it is -5. Somewhere here. Okay, and then you draw the line, join those points. Basically, this is how you draw the graph of a function given like this. Okay, so this is actually the full function. Okay, it is not piecewise. What do you mean by piecewise? You have seen that in the college algebra. Piecewise function is defined in different pieces like this. Okay, so this is for x greater or equals to 0, meaning at the positive side the function is x plus 1. And at the negative side, the function is x minus 1. So let us draw the graph of this piecewise function, okay? And then we will see how to draw the graph of piecewise function there. So let me mark those 1, 2, 3, 4, 5, and so on. Similarly, on the negative side of x and y, okay? This is the graph or the grid, okay? Now, for x greater or equals to 0, you make a chart. For x less than 0, you make another chart. You see that? Now, so for x greater than 0, the chart will be, I will be picking x values from that region only, meaning from right side of 0 only. And for x less than 0, I will be picking the values to the left of 0 only, okay? And then plot the points that way. Okay, for x greater than 0, the function is x plus 1, okay? So y equals to x plus 1. Here y equals to x minus 1. Okay, let us plot x equals to 0. I can plot 0 because what it says is you can plot 0 or greater than 0. Okay, at x equals to 0, y will be 1. At x equals to 1, y will be 2. At x equals to 2, y will be 3. At x equals to 3, y will be 4. You see that? This is what you get. Okay. Now, what do you see from here is you can pick only those x values that is greater or equals to 0. That's what it says. When x is greater or equals to 0, you pick this function. When x is less than 0, then you pick that function, okay? So, less than 0, let me pick -1. When x is -1, you will get -2. You see that? When x is -2, then you will get negative 3, negative 3, negative 4, negative 4, negative 5. Okay, now I want to draw the graph of this function. Okay, so how do I draw the graph of that function is, let us plot this first. At 0 it is 1, at 0 it is 1, at 1 it is 2, at 2 it is 3, at 3 it is 4. So this is one part of that graph, one piece of that graph, and it keeps going, right? Because we can pick any value of x greater than 0, right? And for this function, at negative 1 it is negative 2, at negative 1 it is negative 2. You see that? At negative 2 it is negative 3. At negative 3 it is negative 4. At negative 4 it is negative 5. And so on. So if you expand this, it goes here, right? If you expand this, but you cannot expand beyond 0 though. At 0 it is 1. So at 0 we write open circle here. That is an open circle there. Meaning at 0 it is 1. You look at the closed circle there because it is closed interval, right? Closed array there. But at 0 you pick this function, that is 1. But at negative 1 you pick this function. So how about at x equals to negative 0.01, you pick this function, right? All the negative values, that's what it says. For all the negative values you pick this one. So at that time you will have to pick this function and then see the height at negative 0.01. Okay, so which will be close to 1, that will be 0.9, negative 0.9, right? So basically when this function is not continuous, right? Because there is a break at 0. You see that? This function is not continuous. Continuity means there is no break. But this function has a break. So this function is not continuous. We will talk about the continuity in details later. But for now, this has two different pieces. And this keeps going to the left. And that keeps going towards the right. You see that? So if I ask you what is the height of the function at x equals to 0, it will be 1. You look at the closed circle, not the open circle, at 1. It looks like at 1 there are two graphs, that is true, but at 0 there are two graphs, okay? But you look at the one that has the closed circle for the height or for the functional value, okay? So you can say that what is f at 1? If you want to find f at 1, you look at this function, okay? F at 1 is, at 1 it is 2, right? And f at negative 1, if you look at the negative 1, the height is negative because it is below x-axis. So that will be negative 2. You see that? How about f at 0? F at 0, you look at the closed circle one, you look at that one. You see that? So you look at the top one, that will be 1. Okay, so this is how we find out, we draw the graph of the piecewise function and find the functional value in case of the piecewise function. Okay guys, thank you. So in the next video I will start section 1.2, which is the limit.